The presence of fluoride in toothpaste can prevent tooth decay. Therefore, most of the toothpastes contain fluoride in it. But how much fluoride is added to toothpaste? If your toothpaste contains more fluorine, it may result in spotted teeth. Undoubtedly, there will be a permissible limit of fluorine that can be added to the toothpaste. Here arises a need for expressing the concentration of a component quantitatively. In this video, we will discuss the different methods of expressing concentration. In fact, concentration can be expressed both qualitatively and quantitatively. First of all, we will discuss the qualitative methods of expressing concentration. Qualitatively, concentration can be expressed as concentrated and dilute. Suppose you have 2 glasses of water of equal quantity. To one of the glasses, you add 5 spoons of salt, and to the other, you add 2 spoons of salt. Which is concentrated and which is dilute? You will say the first one is concentrated and the second one is diluted. However, you cannot say how concentrated or how dilute it is. Thus, a dilute solution has a relatively very small quantity of solute compared to the solvent, while a concentrated solution has a very large quantity of solute than solvent. Though useful, this qualitative method of expressing concentration often leads to confusion. Hence, there arises the need for expressing concentration quantitatively. Thus, quantitatively, concentration is expressed in terms of mass percentage, which is denoted by weight, and volume percentage, which is denoted by V by V, and mass by volume percentage, which is denoted by W by V, and parts per million, mole fraction, molarity, and finally molality. We will see each in detail. Let us start our discussion with the mass percentage, also denoted by weight. Mass percentage of a component in a solution is the ratio of mass of the component in the solution to the total mass of the solution multiplied by 100. That is, for example, a 20% weight by weight solution of sodium chloride is made by mixing 20 gram of NaCl and 80 gram of water, which is making a total of 100 gram of solution. Another way of expressing concentration is volume percentage. The volume percentage of a component in solution is defined as the volume of the component divided by total volume of the solution multiplied by 100. This method is generally used when both the solvent and solute are liquids. For example, a 10% solution of ethanol in water means 10 ml of ethanol is dissolved in 90 ml of water, such that total volume of the solution is 100 ml. Another unit which is commonly used to express concentration is mass by volume percentage. It is the mass of solute dissolved in 100 ml of solution. For instance, a 33 weight by volume percentage means that 33 gram of solute is dissolved in 100 ml of the solvent. The next way of expressing concentration is parts per million. Parts per million is defined as the parts of the solute per million parts of the solution. Mathematically, it is written as the ratio of the number of parts of the component to the total number of parts of all the components multiplied by 10 raised to 6. This is usually employed when the solute is present in very trace quantities. For example, the amount of carbon dioxide in the air or the concentration of dissolved oxygen in water, etc. are usually expressed in ppm or parts per million. You can say the amount of dissolved oxygen in seawater is 5.8 gram per 10 raised to 6 gram of seawater. Note that ppm can also be represented in terms of volume by volume or as mass to volume. Now, let us discuss mole fraction. The mole fraction of a component is the ratio of number of moles of that component to the total number of moles of all the components. Mole fraction gives the concentration of various components in a mixture. If in a binary mixture with components A and B, Na and Nb are the number of moles of A and number of moles of B respectively, then the mole fraction of A is given by Xa equal to Na divided by Na plus Nb. Similarly, you may write the mole fraction of B as Bxb equal to Nb divided by Na plus Nb. Note the total mole fraction Xa plus Xb equal to 1. Thus, in general, for a solution containing I components, you may write the mole fraction of the ith component Xi equal to Ni divided by N1 plus N2 plus etc. plus Ni. This can be generally written as mole fraction of Xi equal to Ni divided by sigma Ni. Yet another way of expressing concentration is molarity. Molarity is defined as the number of moles of solute dissolved per liter of the solution. Recall that the ratio of mass to molar mass gives the number of moles. Let us solve this numerical problem so that you will understand the concept of molarity more clearly. A solution of sodium hydroxide was prepared by mixing 10 gram of NaOH in 500 milliliter of solvent. Then calculate the molarity. Here, molarity M is given by moles of solute divided by the volume of solution in liter. The first step is to calculate the number of moles. Next, you write molarity equal to mass of NaOH divided by molecular weight of NaOH multiplied by 1000 divided by volume of the solvent. By substituting the values, you may get molarity of the solution as 0.5 moles per liter. Finally, we will discuss molality, which is the number of moles of the solute per kilogram of the solvent. Now, let us try to solve this numerical problem. You have to calculate the molality of a solution given that 10 gram of NaOH is dissolved in 25 gram of water. Here, the first step is to calculate the number of moles of NaOH, that is equal to 5 divided by 58.4, which is equal to 0.086 moles. Next, you may calculate the molality as moles of solute divided by mass of solvent in kilogram. By substituting the values, you may get molality as 3.44 molal. Here is another numerical problem for you. Can you calculate the mole fraction of alcohol in a solution containing 4 moles of alcohol and 8 moles of water? Here is a hint for you. You may try to solve it by yourself. Now, we will summarize this video.
Manorama Horizon. Learning made simple.